Alright, so it's Unit 7 Quadratics, Day 2, graphing. With this first problem, what we're doing is it says, what's the maximum of the function y equals negative x squared plus 16x plus 7, determine the domain and range. Very first thing I'm doing is identifying that it's actually wanting the vertex. Last time we were in class, we were talking about how to solve with the quadratic formula. So that was where it was going to be a y value of 0. Today I'm actually interested in the vertex is the difference. So I'm not actually going to be using that. I'm going to actually be doing negative b over 2a is the focus of today. So that's where I start the problem at. That's not going to be everything on the problem. Basically what I need to do next is go ahead and plug in my a and b value to the formula. Now here a is negative 1. When there's nothing there in front of x squared, it's a 1. B is positive 16. C would be 7. Doesn't really impact us right now on finding the x value of the vertex. So x equals, I'm going to go ahead and substitute those values in. Negative, b was 16, so that's what I'm going to go ahead and put in there. Over 2 times a is negative 1. And so yeah, I'm going to go ahead and simplify that down. That's going to be negative 16 on top. 2 times negative 1 on the denominator would be negative 2. Negative 16 divided by negative 2 is 8. So x equals 8 is my x value of the vertex. I'm going to reference my graph that I sketched out really quick. So wherever this vertex is, it's got an x value of 8 is what I've already figured out. I got to find the y value now. So next thing that you got to do is you actually just got to plug in that x value of 8 into the function and see what it gives you in your calculator. Y equals, so I'm going to be typing into my calculator negative 8 squared, and this is coming from using the function is what I'm doing. Just using this function and replacing the two x values with 8. Plus 16 times 8 plus 7. You got to be very careful to use parentheses correctly here. So don't use y equals on your calculator when you're typing this in. Just type in this part on the home screen and see what the value is. So if you typed it in correctly, you should have gotten 71 for y. So anyways, I've got two questions on this, two parts to this problem. Now I'm ready to answer them both. I'm going to go ahead and pencil in the 71 for the y value up here. Alright, we're finally ready to actually answer the problem. What is the maximum value? Max value is 71. That was one of the two answers I was looking for here. For domain, it's pretty straightforward. It's always the same thing for quadratics. That's all real numbers. And the reason for that is simple. Any number that you could come up with for x could be plugged into this function. There's no restrictions on it. There will be with different functions, but with quadratics, it's always going to be all real numbers for any normal scenario. Now, you will have word problems where that will change based off the context of the word problem, but we're not really worried about that in Foundations Math 2. We'll worry about that more in Math 2. Alright, now my range. Very straightforward. I've actually got all the information I need. Range is the y values. So here it's going to be y is less than or equal to, because the graph is going down from the vertex, and this was the highest value was 71. So y is less than or equal to 71. Whatever, if it's a maximum value, it'll be less than or equal to that value. If it was a minimum value, it'd be greater than or equal to. And there's my other answer I was after on this problem. So what happened on this problem is if you're looking at your graph, it actually doesn't show up too well. So I'm going to actually be doing this problem on this graph paper provided, but if you want to use your own graph paper, you can. Notice I also established that this is a scale unit of 2 on each axis. So that's what I'm going to be using. You could just put in tick marks on the axes that are on your notes to make the graph paper work for you. It says graph it, state the domain and range. So I'm going to go ahead and show you how I could use the calculator to basically do what I did on the previous problem. So the very first thing I'm doing when I grab my calculator is I go ahead and hit y equals, and I will type in the function that they're giving me. The 1/2 So 1 divided by 2, x squared plus 5x plus 2. And I'll go ahead and graph that by hitting the graph key on the calculator. Now, if your graph does not come out as pleasantly as this one did that I just graphed, and your screen is messed up, what you should do is go ahead and hit the zoom key and hit 6 for zoom standard. So I'm going to hit the 6th option for zoom standard. That'll actually reset your graph to what it's supposed to look like. As far as figuring out the vertex, I really recommend you to go ahead and use negative b over 2a. I'm going to do that in a slightly different way, where I'm going to do so in the home screen of the calculator. So I'm going to right now hit second quit to get out of the graph right now. And to do negative b over 2a, I'm going to hit alpha F1, which is the F1 is on the y equals key, and hit enter on n over d. Now I'm going to type in negative b over 2a. So now I'm going to be hitting negative b over 2a. When I do that, I'm going to hit the negative key here at the bottom, not minus. So negative, put parentheses for your b value, which in this case is 5. Close parentheses, arrow down to enter the denominator, which will be 2 times a. So 2 parentheses a, which is 1/2. You could put 0.5 instead of 1/2 and hit enter. I get negative 5 for my negative b over 2a. Anyways, what we're supposed to be doing now is go ahead and figure out what the vertex is. This is my x value that I just calculated, which is negative 5. So what I'm going to do is go ahead and hit the trace key. And I'm going to type in a negative 5. And you can see it's putting that in for x, like I said. And I'm going to hit enter. So it'll tell me the vertex is negative 5, negative 10.5. It's actually right here where I'm pointing at with the arrow right now. I'm going to go ahead and graph that, make a sketch of my graph, and be good on this. So let's go ahead. And what we're doing is we're going to go ahead and graph that. So negative 5, negative 10.5. So I'm going to graph that point that I just got from my vertex. I'm counting by 2's here, which is the reason why the location's a little strange. 2, 4, 6, 8. 10.5 right there, and there's my vertex. I'm going to go ahead and label it negative 5, negative 10.5, and I'm going to go ahead and just make a rough sketch of the parabola. You don't need to get exact on where the rest of the points are. That's kind of whatever. You could look those points up, but this is what I'm looking for.
Oh, mine looks fine.
Alright, to wrap this up, this was a minimum value because the graph was opening up. And that minimum value was negative 10.5. Now I'm going to also do domain and range. So the domain, like I said, is always all real numbers. Let me go ahead and write that in here. And then your range is not going to be less than or equal to on this one. The reason why it's going to be greater than or equal to is because this was a positive function. Now, also a detail here is it's going to be f of x, not y. So it's going to be f of x is greater than or equal to negative 10.5. Now, what you might be wondering is, do I have to use the calculator like we just did here? The short answer is no. I was using the calculator to show you a different tactic that could have been used. You could have done what we did on example 1 instead. Alright, and if you're wondering who kept interrupting this video, it was Cam. So thanks for having patience as we went through this. Would y'all like to say hello to everybody on YouTube?
Yeah.
There you go. Good job, guys.
Oh, I want to say hello.